So let's graph the following. Let's graph this line with slope 4/3 and y-intercept -4. Remembering that my slope is rise, which is my change in y, over run, which is my change in x. So let's graph our y-intercept. So my y-intercept is -4, so when x is 0, y is -4. And my slope is 4/3. So how would I use this to find the next point in my graph? Well, my slope is 4, which is my change in y, so I could go up 4, 1, 2, 3, 4. And then my change in x is 3, 1, 2, 3. I found another point on this line, which is conveniently my x-intercept. Let's find another point. So I would go up 4 over 3, right? That allows me to find additional points on my line. Knowing my slope and my intercept, I could put this into slope-intercept form because I substitute in. I know m is 4/3 plus b, which is -4. So the equation for this line would be y equals 4/3 x minus 4. So let's graph the line through 3, 1. So I'm just told a point on the line. I don't know the y-intercept. And a slope of -4. So that means my graph is going downhill. Slope, remember, like I said, is rise over run. Well, in order to make this have some kind of run, right, we have to write it as a fraction over 1. So let's plot this point. So when x is 3, y is 1. And I'm going to go down 4, so it's my change in y, which is negative, over 1, down 4, over 1, and I could keep doing that to find even more points on my line. So there we have the graph of our line, and I don't know my y-intercept, and I don't have the tools at this time to calculate the y-intercept, but we will, I promise, and then we could find the equation for this line. So how do I graph lines in y equals mx plus b form using the slope and y-intercept? So the first thing you want to do is you want to graph the y-intercept. You want to use the slope to determine where the next point is. Remember, you need to find at least 2 points and connect them. So here I have y equals 2x minus 3. My slope is 2. I'm going to write that as 2 over 1, so I know it's rise over run. And my y-intercept is -3. Because my slope is positive, my graph is going to look like it's going uphill. That's a great way to check yourself. So let's go to y-intercept -3. So when x is 0, y is -3. And my slope is 2, so I'm going to go up 2 over 1, and that's another point on my graph. Now I only need to find 2, but I'm going to show you how to find a couple more because I think the practice is really good, right? We go up 2 over 1, up 2 over 1. You can kind of notice this pattern. Looks like a little domino piece that we're connecting the corners of. So there's the graph of our line. Let's try this again. My y-intercept is 4. My slope is -2/3. Remember, because my slope is negative, my graph is going to look like it's going downhill. So let's plot our y-intercept. My slope is my change in y, or my change in x, right? So I'm going to go down 2 over 3. Down 2 over 3. Oh, hey, I found my x-intercept. That's exciting. Okay, it is for me. So let's go ahead and, oops. So let's go ahead and graph this. There we go. So we've graphed the line y equals -3, 2/3 x plus 4. Now, if I have x equals a constant, that graph is always going to look like a vertical line. And we say this line has undefined slope. If I have y equals a constant, that graph is always going to find a horizontal line. And we say that this line has 0 slope. So why don't I go over why we say x equals a has undefined slope and y equals b has zero slope mathematically. So remember, my slope is my change in y over my change in x. So let's pick 2 points on this line. I have when x is 3, y is 2, and when x is 3, y is 0. So here's my x1, y1, x2, y2. Am I all on the same page so far? So I'm going to take my change in y, which is going to be 0 minus 2, over my change in x, which is 3 minus 3. So I get negative 2 divided by 0. Oh no! I can't divide by 0. We can never divide by 0 in mathematics. That's why this slope is undefined. Let's figure out why this line has 0 slope. So let's pick 2 points. I've got when x is 1, y is 5, and when x is 6, y is 5. Those are just the first points. x1, y1, x2, y2. So let's look at my change in y, which is going to be 5. I don't know why I put a parenthesis there. 5 minus 5 over 6 minus 1, so I get 0 over 5, which is 0, because we can divide a number by a 0 by a constant. We just can't divide a constant by 0. So if two lines have the same slope, they are parallel, and they can have a slope that's positive, right? Those two lines are parallel. Negative, 0, or undefined, right? All these little examples of lines would be parallel, as long as they have the same slope. One thing that's true about parallel lines is because they stand beside each other forever and ever and ever, they never intersect. That'll come in handy in section chapter 3. So let's determine whether the following are parallel lines. So I already know the slope of this line is 3/2. I now need to solve for the slope of this line. So I'm going to go ahead and divide both sides by 2. So I get y equals 3/2 x minus 3. So this line also has a slope of 3/2. It's just its y-intercept is different. So these lines are in fact parallel. If two lines are perpendicular, that means they intersect at a 90-degree angle. And when two lines are perpendicular, the product of their slopes is -1. So the lines are negative reciprocals. So for example, if I had a line with a slope of -1/4 and a line with a slope of 4, because these are reciprocals and one's negative, the product of this would be -4/4, which is -1. So lines with these two slopes would be perpendicular. Horizontal lines and vertical lines that intersect are perpendicular as well. And they wouldn't have a product of their slope of -1 because vertical line slope is undefined. So let's determine if the following lines are perpendicular. So first I need to get both of these into slope-intercept form. Divide both sides by 2. Y equals 3/2 x minus 3. I'm going to subtract 2x from both sides. 3y equals -2x minus 6. Y equals -2/3 x minus 2. So in order to determine if these are parallel, I'm going to multiply the slopes together. And if their product is -1, which shock and awe it is, these two lines are perpendicular.